Hi, hello friends. Welcome to the today's session and welcome to Unacademy. Welcome to Srinivasrao Sir classes. So today we are going to discuss about the join operators. What are the importance of join operators in relational algebra? So my dear friends, before starting to the lecture, let us say our anthem. Crack GATE and ESE with India's largest learning platform and none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. My dear friends, Unacademy has created a wonderful interface between students and the topmost faculty members. And you can able to utilize this opportunity, get the admission into Unacademy and access unrestricted. So you're going to see that unrestricted live classes, mock sessions, live quizzes, and doubts clearance. Everything we are available in Unacademy portal. You can able to use everything which is available in Unacademy portal. All you need to do is give your valuable admission. Then Unacademy is going to take care, and we too take care on behalf of Unacademy. So, my dear friends, about myself. Srinivasarao IS, having more than 15 years of experience in the GATE subject. So throughout my journey, I taught in many premium academies with a high success rate. Many of my students completed their post-graduation in topmost institutions like IIT, NIT, and IIIT. And many are working in a topmost MNCs. We also can have such kind of wonderful opportunities just by clearing prestigious competitive examination such as GATE. Utilize this opportunity. So to crack this GATE examination, there are need of some tips and shortcuts in the various subjects. So GATE examination is a very easy examination if you are having tips and shortcuts with. So here we are going to present such kind of tips and shortcuts so that you can able to clear your competitive examinations in easier manner. So my dear friends, there are two kinds of subscriptions as per GATE and ESE concern. So 12-month subscription can opt by current fourth year students, and 24-month subscription can opt by third and fourth and second year, and even first year students also can start their GATE program in the first year itself. Because a GATE CSE is a core of 10 competitive subjects. They are going to start from first year itself, known as the C and data structure. So my dear friends, so the current fourth year students can opt a 12-month subscription and the rest can opt 24-month subscription. The subscription is going to provide unlimited content, as you also need unlimited content and unlimited tips and shortcuts by various faculty members. So my dear friends, today itself you join in Unacademy because subscription prices may be likely to increase. That's why before increasing of the prices, you start take the admission today itself. And apart from that, if you use my referral code, then you are going to get a good amount of discount, which is offering by Unacademy. As I told you, Unacademy is working towards the perspective of the students. Whatever student need, the Unacademy is ready to provide, and we too on behalf of Unacademy. So my dear friends, Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel and use my referral code to get the maximized discount for any kind of a course, not only for GATE and ESE. It is for IIT, JEE, CAT, UPSC. You can use my referral code and enjoy the maximum discount. And hit the bell icon for latest notifications and updates. So now let us start our agenda. What is that? The join operators. How are you going to use them in relational algebra? So In your mark scoring, especially from DBMS side, 2 marks we going to expect from SQL and 2 marks we are going to expect from algebra. So that's why algebra also very much needed to score the marks in easier manner. It's not that much difficult. If you know the rules, you can win the relational algebra. One of the first join operator is cross product. So what is a cross product? The cross product is nothing but all the rows of one particular relation is going to map with all the rows of other particular relation. So what are you going to get? Minimum and maximum. How many minimum tuples you will get from the cross product and how many maximum tuples you are going to get from cross product. Minimum tuples you are going to get from cross product is 0. And the maximum tuples you are going to get from cross product is nothing but multiplication of your m and n rows, nothing but mapping. So to any kind of a join you want to perform, the first step is nothing but cross product. So how the cross product is going to be useful, especially in relational algebra. Now if I'm saying like this, so when we are talking about the relation R and when you are talking about the relation S, and there are two attributes I am taking AB and there are other two attributes I am taking CD. And we have some values like A1 and B1 and A2 and B2. And here we have C1 and D1 and C2 and D2. My dear friends, if anybody asks you what is R cross S, so what is the minimum it will give you and what is the maximum it will give you? So in that case, the minimum and maximum depends on your R cross S only. So minimum there may be a chance of 0, but according to this example, the minimum and maximum, as there are some rows are available, then I can able to confirm that it is a crossing. So how many columns you are going to get? This is a very important point. And how many rows you are going to get? I already revealed the rule for rows, which is nothing but 2 into, for example, if I say 3, 3 and D3, then 2 into 3 you are going to get a 6 rows according to that. How many columns? So the columns are in the form of addition. So columns are in the form of addition and the rows in the form of multiplication. So how many columns you are going to get? 4 columns. And how many rows you are going to get? 6 rows. And when are you going to say that what is the minimum value? If I am saying the same example, if I am considering there is a R which consists of AB here and there is a S which consists of C and D here. And I am saying, my dear friends, there are few tuples here, A1 and B1, A2 and B2. There are no tuples in S. If I am asking what is R cross S, now you see that the R cross S is a 0. So minimum there may be a chance of 0, maximum you can say, according to the example you need to say that. So it is R cross S as a maximum. So sometime he may also ask you like this. There is a relation R which has got AB and he said that two tuples are there, A1, B1 and A2, B2. He is asking R as R1 cross product R as R2. Now he is asking how many columns and how many rows. So here the R is used as a two instances. One is in the form of alias of R1, one is in the form of alias of R2. So therefore R is being divided into two particular relation instances. So it itself is a performing Cartesian product or cross product. So here a number of columns are as usually 4 because R1 plus R2 and number of rows. Now you can say that R1 cross R2. What is R1? Your R1 is R only 2 rows. What is your R2? Your R2 is R only 2 rows. I can confirm the 4 rows. Now, if I'm saying like this, observe carefully. I say R with A and B and S with C and D. And there are some data tuples are available here. A null D1 and a C1 and null. If you ask that what is R cross S, how many number of tuples? He is asking tuples. So now I can perform here R cross S. So here the minimum and maximum, if we ask that, so I can able to map, because A1 B1 is mapped with a null and D1, because there is a some tuple value in some of the attribute, and A1 B1 is mapping with C1 and null. So here I got, this is what is the meaning of R cross S. Let me present one more example here. R has 2 rows, S has 4 rows, and T has 2 rows. If I'm asking all together 0 rows, if I'm taking, if I'm saying all together what is R cross S and what is R cross T and what is S cross T and what is R cross S cross T, now you can say the answer, as I already told you the tip. So R cross S, it's a 2 4s are 8 rows, and R cross T, so 2 into 0, it is a 0, and S cross T, 4 into 0, it is a 0, you cannot able to map, and R cross S cross T, it is a 2 into 4, 8 into 0 is nothing but 0. So this is how I can confirm the cross product. Okay, my dear friends. Now let us see one more join. The main drawback of your cross product is nothing but a duplicity of the tuples. So this duplicity you want to eliminate. Then there is a requirement of what? P-join, or there may be a requirement is called a natural join. So before discussing equi-join and natural join, I would like to discuss about conditional join. So what the conditional join is telling you. So in order to avoid the Cartesian product, that means a duplicity of the data, you can able to use a few of the joins. One of the join is, so we want to eliminate the duplicity which is there in a Cartesian product. I am using a conditional join, the other one equi-join, the other one a natural join. So these are the joins which are there. Apart from that, we also have the concept outer join. Now let us see the first variety of join which I would like to discuss is a conditional join. That means the joining of the tables based on a condition. So that is the meaning of a conditional join. You can able to mention like this. What is that? I can have R conditional join S using like this. What is that? The first step is R cross S only. The second step is a what? Condition over that. So this is another example for conditional join. Is that R cross S I am doing. So I am going to ask a condition on your cross product. You all may have a doubt why I am doing a cross product. Because for any kind of a join, the base is cross product only. On the result of the cross product, you may go for conditional join, you may go for equi-join, or you may go for natural join, or you may go for outer join. Any kind of a join you may use on the Cartesian product only. So the basic step for any kind of a join is a Cartesian product. So let me do one example with a conditional join. I say there is a table R which consists of some AB, 2 columns are there, and there is a table S which consists of C and D. Two columns are there. So conditional join is a 2012 GATE question, my dear friends. And even 2020 also similar question is there. And I am saying like this, A1, B1 and A2, B2. I am asking here as like that A3, D3, and I am asking here A4 and D4. I say R is going to join with S based on a condition. What is that condition? Observe carefully. R dot A lesser than S dot C. This is the condition. How many rows are going to get by this? So the first step to do any kind of a join, I said, is the Cartesian product. So what is your Cartesian product? You say A1, B1 is going to be done with A3, D3, and A1, B1 is going to do with A4 and D4. So two mappings completed. Next mapping is A2, B2, A3 and D3. And next mapping is A2, B2, A4 and D4. My dear friends, take the columns now. So it is A, B and this is C and D. After completion of the first step, we want to apply this condition. What is the condition? If R dot A less than S dot C, let us see, A1 is less than S. So you are going to get the first tuple A1, B1, A3, D3. A1 is less than A4, yes, you will get this. A2 is less than A3, yes, you will get this. A2 is less than A4, yes, you will get this. So how many rows you are going to get? According to that, we got 4 rows. Now let us project one more example over here. Now I say R with M and N and S with P and Q. We have some data here, 10N1, 5Q1 and 15Q2. He is asking simply R join with S using some condition. What is the condition? Your R dot M greater than S dot P. Now you decide how many rows are going to get. My dear friends, before generation of output, I want to give one advertisement that from tomorrow onwards, we are going to launch a computer networks full length course. The timings are from 10 p.m. to 11 p.m. Please don't miss this opportunity. From basics to advanced level, I'm going to teach. So from tomorrow onwards only, 10 p.m. to 11 p.m. the session's timing. So let us see the output of this. What is that? So first step is your cross product only. R into S is supposed to do. Don't forget any kind of a join. This one you're supposed to do. So 10N and 5Q1 and 10N1, 15Q2. So what is the condition? R dot M greater than S dot P. So 10 is a greater than S dot P. Then you're going to get this tuple. And 10 is a not a greater than this 15. Then your answer is not there. Then only one row you're going to get from. So this is how you can able to use the concept of what? Conditional join. So here I'm not going to get Cartesian product. Cartesian product is nothing but I need to get a two tuples, but I'm not getting two tuples because I have applied the condition. What is the condition? Any valid condition you can keep to escape from your Cartesian product. So Cartesian product you want to escape, then there is a requirement of at least you can use the concept of a conditional join. So this is a YouTube, the starting lesson, starting class is from tomorrow only. YouTube, it is a free classes. So please join. So 10 p.m. to 11 p.m. Now we want to go for equi-join now. So what is equi-join? It is based on equal data on the specified common column. So it is based on equal data on the specified column name. Now it is also going to eliminate your Cartesian product or cross product. Let me show you one example. Very critical example are there, especially in equi-join. I say you observe carefully. There is a R which consists of AB here. There is a S which consists of A and C here. Observe, my dear friends. Now I am saying 10 and B1 and 10 and C1, and I am saying here 20 and C2, and I am saying here 10 and B1. Now I am asking a query. What is that? R join S with a equal condition, not a conditional join. I am using condition using a equal operator. That's the meaning. R dot A is equal to S dot A. This is also one kind of a condition only, but the condition based on common data on the particular specified column. Now first step is as usual your cross product only, which is a 10B1 and 10C1, and the second step is a 10B1 20C2, and next step is a 10B1 and 10C1, and next step is a 10B1 and 20C2. My dear friends, this is R dot A, and remaining I don't need, this is S dot A. Now you want to pull the tuple, this condition must be satisfied. What is this condition? Equi condition. Earlier I have used less than, greater than, some other. Now I am using equi condition. Now you decide this 10 and this 10 is equal, and this 10 and this 20 is not equal. This 10 and this 10 is equal. This 10 and this 20 is not equal. Now you got, it is retrieving 10B1, 10C1, and now it is also retrieving 10B1 and C1. Now tell me, my dear friends, will it return two rows or will it return only one row? This is my question to you. As the rows are duplicated, will it return only two rows or will it return only one row? That you please provide through comments. Whether the same tuple will be reprinted or it is going to eliminate another tuple, that you need to tell to me. So you can type through chat. What is that? Whether two rows or one row. Now let me present one more thing here. As I am saying A and B, as I am saying A and C, observe carefully. So 10 and B1 and 10 and C1 and 10 and C2. If I am asking R join S using R dot A is equal to S dot A, on that I want to take only column A. Please observe carefully. On this I want to take only column A. So now you see 10B1, 10C1. Now you see 10B1, 10C2. And this is your R and this is your S. Now let us cross check. R dot A is equal to S dot A. This is the condition to us. Now you tell me answer so that you will understand what is the answer of the previous, my dear friend Ajay. So this 10 is equal. So it is going to retrieve. This 10 and this 10 is equal. Therefore it is going to retrieve. On these two tuples, I am calling what? Pi of A. This pi is going to eliminate the duplicates. Observe carefully. This eliminate the duplicates. And now you are going to get pi of A. That is means A, you are going to get answer as what? 10. But once you look at the previous one, what is that? It is going to return two rows as I am using the concept of what? Selection. But you understand carefully, all the relational algebra operators are trying to eliminate the duplicates. Hence, your answer is what? One row in this case. So, my dear friends, to observe carefully, here the projection operator is trying to eliminate the duplicates. So, your answer is what? 10 in this. Now, let me give you one more example. Now, I say R of A and B, S of A and B here. Observe carefully. So 10B1, 20B2, 10B3, 20B3. I'm asking R join S using a condition, equicondition. What is that? R dot A is equal to S dot A. Please observe carefully. And R dot B is equal to S dot B. Now you tell me how many rows you are going to get. So the answer is this 10 is equal to this 10, but this B1 is not equal to this B3. And this 20 is equal to this 20, but this B2 is not equal to this B3. Hence your answer is 0 rows. Because one condition is satisfied and other condition is dissatisfied. So both the conditions need to satisfied as I am using AND operator. Let me give the same example this time in a different way. I say R with AB and S with AB. Observe my dear friends. This is an AND operator. It's not OR operator. OR operator means I will show you. If you want, I will also show you. Don't worry. So 10B1 and 20B2. This is a 10B2. This is a 20B3. I'm asking you, R natural join yes or R join yes on the condition. What is that? R dot A is equal to S dot A and observe carefully. R dot B not equal to S dot B. Now you tell me how many rows you are going to get. So the first step is as usually cross product you need to write. What is the cross product? So 10B1 and 10B2, and I am saying here 10B1 and 20B3, and I am saying here 20B2 is mapping twice 10B2 and 20B3. Now you decide how many rows are going to get. R dot A is equal to S dot A, exactly matched. And R dot B not equal to S dot B. Yes, it's not equal. Then you're going to get the first tuple. Next to this and this is not satisfied. First condition is a fail. So 20 is not equal to 10. First condition is a fail. And 20 is equal to 20. Let us move to the second condition. The B is not equal to that. Yes. Now you got 2 rows from this. This is how you can test the concept of equijoin. Now let me project one more example here. If I am using R, what will happen? I say there is a R of AB. So 10 and B1 and 20 and B2. And S I am using A and C. 10 and B2, 20 and B3. I'm asking a condition over here. What is that? R is going to join with S. You can also write like this. R is going to join with like this. R dot A is equal to S dot A or R dot B is equal to S dot B. Now you observe carefully. Either of the condition can be satisfied. Let us see the mapping now. So 10B1, 10B2. And the second mapping is 20B2, 10B2. Another mapping is 10B1, 20B3. Another mapping is 20B2, 20B3. Now you observe. R dot A is equal to S dot A. Exactly, it is matched. So your answer is 10B1, 10B2 you got as the first condition is satisfied. We will check the second condition later. So 20 is not satisfied. This won't come. 10 is not satisfied. It won't come. This and this you will get. What is that? 20B2, 20B3. First condition over, less. Come to the second condition. What is that? R dot B is equal to S dot B. So this and this not satisfied, but this and this is satisfied. So write that tuple also. 20B2, 10B2. Observe carefully. And this B1 and B3 not matched. B2 and B3 is not matched. Now you tell me how many tuples you are going to get. So all are unique tuples only. Observe carefully. 10B1, 10B2 is unique tuple. 20B2, 20B3 is unique tuple. 20B2, 10B2 is a unique tuple. Then your answer is in this case what? Observe carefully. If there are any duplicates are there, the OR is going to eliminate it. OR is going to act as a what? A unique tuple it is going to give you. That's the meaning of a plus. So before it is returning your answer, it sees that any tuples are being duplicated or not. So before going into the discussion of the questions, let us see what is a natural join. It is an associative operator, very, very important. What is associative operator? I can say it is also commutative operator. What is a commutative operator and associative operator? Observe carefully. AB implies C is equal to A implies C and B implies C. I can write like this. So you can able to write like this, which means that a reverse also is going to be done. That means what? When I am saying AB implies C, I can able to write in this form. If I am saying that AB implies C, commutative means what? The reverse also is going to be true. That's the meaning of commutative, C to AB. Or if I am saying that A implies B, then the commutative is nothing but B implies A. Let me show you one important example here. R is a join with S. Reverse also true. S is a join with R. This is not possible in all the cases. Very few cases. What is that? Cross product also I can write like this. But a conditional join cannot able to write. And equal condition, sometime you write, sometime you cannot write. But these two are mandatory as their eligible what? Commutative nature. And what is associative nature? Let me write like this. R join S join R. I can write like this. R join S and join R. This is also correct. And other style is also there. For example, if it is the other style is also there. What is that? R join T. I can able to join with S. The same rules is also applicable for what? Cross product also. There is no restriction how you want to use. And natural join based on three important conditions. The first condition is a cross. This is a very important. And the second condition is a what? Considering all common columns. Considering all common columns. And third important point is that common data it needs. And the fourth important data, duplicate elimination. By default to do duplicate elimination, my dear friends. Very, very important for your exam. Whatever exam you write, you don't mind, you will get a question or natural. Now let us cross check how to do. I say there is a relation with A and B, and there is a relation with A and C. I am saying here 10B1 and 10C1. Observe carefully. Now I am also saying 10B2 and 30C2. If I am asking what is R natural join, yes, directly you can do. How? The common is A. Natural join always looks for common data. So here 10 and 10 is mapped. So I can write 10B1, 10C1. But this 10 cannot map with 30. And this 20 cannot map with 10. This 20 cannot map with 30. Hence you are going to see that only one row. Now let me show you one important another example. There is a R with AB and there is a with A this, and there are some tuples here. Observe carefully. So 40C1, 50C2. He is asking what is a R natural join? Yes, this is your natural join symbol. This I can write in such a way that first I am doing a cross, then I will do condition. What is the condition? Common column R dot A is equal to S dot A. On that I am going to take projection of your common column. Now you tell me this 10 is not possible to map because equal condition, and natural join means a common data. 20 is not common, 30 is not common. I can write answer is how much? 0 rows. Now hold on and look at this example now. I say R of AB. There are some common tuples between them. This is S. And there are some common tuples between them, 10D1 and 20D2. Now you tell me, what is R natural join? Yes, this is my question, first question. And second question is, what R join S using R dot A is equal to C dot A. Observe carefully. So now, who are in the chart can able to answer this? What is R natural join? Yes. Very important question that is. And what is this join? How many rows from this? And how many rows from this? And third also I am going to give you, what is that? R cross S. So how many rows from this? If you look at the first one, R cross S, if you look at, your answer is no doubt 2 into 2. That is nothing but what? 4 rows. And if I am using R natural R join S with R dot A is equal to S dot A. So 10 and 10 is equal, 20 and 20 is equal. Hence, I can able to write here only 2 rows only. But I am saying R natural join S. How many rows you are going to get? So we all see that natural join is looking for common column. As there is no common column between R and S, your answer is how many rows? You're going to get 4 rows here. Why 4 rows you got? To tell me through chat. So you all may get that. You all may think that you are also going to get 2 rows as like your equijoin. That's why equijoin is different from natural join. My dear friends, again and again I am telling you equijoin is different from natural join. You are witness from this example only. So now you see it is going to provide 2 rows, but here it is going to provide 4 rows. Why? Just give me a comment through chat. Why we got 4 rows? Why not got 2 rows? Now you see, if I am saying R and S, here we got AB, here we got AB. Now I am saying 10B1, 10B1, and 20B2, and 20B3. He is asking what R natural join is. So R natural join S is nothing but here it is going to consider 2 common columns. AB is a common and AB is a common. Hence we are going to look at the equality among two columns together. So 10b1 and 10b1 is matched because I am checking on A as well as B. What is its full length query? R cross S. On that, two columns are common to you. So R dot A is equal to S dot A and R dot B is equal to S dot B. All the two common columns you need to write. On that, do select how many rows you have got. That's nothing but phi of AB. Now your answer is, as this is satisfied there and here, then I can confirm 20b2 is different from 20b3. Then you got the one row from this. So this is how about natural join. But sometimes natural join can also be done using like this. How? Sometimes natural join can also be written like this. I'm saying R with A and B and S with A and C. Observe carefully, my dear friends. This is your primary key. And this primary key I am using here as a foreign key. Now he is asking, what is R natural join S? So let me give some tuples here. The tuples are 10b1 and 20b2. And we know that differential integrity, every foreign key value is supposed to be equivalent to your master value, primary key value. So 10c1 and null c2, 20c3 and 10c4, 20c5. I'm asking what is R natural join S? When you ask R natural join S, you need not do such a long process. Simply you can do because he mentioned a primary key and foreign key. If not mentioned, then you have to do however I did. But when there is a primary key and a foreign key is there, your minimum size of a join and your maximum size of a join depends on your child tuples only. So how many are your child tuples? Understand carefully. 1, 2, 3, 4. So your answer is a 4 rows because null we don't consider. Observe carefully. So this is how you can able to easily short out your answer that how many rows are going to get from R comma S. Let me give you one more example. R has 100 rows here. S has 0 rows here or 10 rows. Now he is saying R dot A is a primary key and S dot A is your foreign key. Now he is asking what is R cross S? First question. What is R natural join S is the second question. So even there is a primary key and there is a foreign key, I don't mind, especially in a cross product. Your cross product will give you almost all 1000 rows. It doesn't mind about primary key and foreign key. But what about equijoin? It looks the primary key and foreign key as you specified master table and child table. I said minimum size of join and maximum size of join depends on your child instance only. What is your child instance here? S is a foreign key, hence I can confirm that your answer is a 10 comma 10 in this. Because I already shown you a process. What is the process? Every child value is a subset or equivalent to your master value. So as many child rows are there and you are going to see that those many values. Now let me do one more. R with AB has got 100 rows, and S with BC there are 10 rows. Observe carefully. T with CD there are 0 rows. Observe, my dear friends. This is a typical example I am providing you. So check your caliber in this example. B is a primary key here, and this B is a foreign key here. This C is a primary key here. The C is a foreign key here. Now tell me, are natural join yes? First question. So you understand that between R and S, which is a child and which is a master, as this is a child, as this is a master, so child has got 10. The answer is a 10 comma 10. If I am asking S join T, between S and T, the common column is SC, and T is a foreign key table. This is a child and this is a master. As a child have 0 rows, your answer is also 0 only. Observe carefully. If I am using R join S join T, observe carefully. I am merging all three. R and S, there is a common tuples 10 is observed. And S and T, there is a common tuple 0. So this one and this one I merged together. Now what is your final answer? Answer to my question through chat. Is it a 0 rows or you are going to get a 10 rows? That's what I want to ask. Very, very typical query. You can judge yourself how good grip you are having on join operators. Again, I am telling you, the first query is R natural join yes. Between this and this, S is a child, so we got 10 rows. And S natural join T. Between master and child, the child is 0 rows, so we got the 0 rows. And R natural join S natural join T. R natural join S is a 10 rows. And S natural join T as a 0 rows. Now you tell me, what is R natural join S natural join T? And my fourth question is, like this. R natural join T is all of you. Answer to this question. R natural join T, how many rows? And my fifth question is, those who are on live, please you produce your answers, my dear friends. And my fifth question is, R natural join S natural join T, how many rows? And my last question is, R cross S cross T. This is another my question. So I will release the answer for R cross S cross T. What is R cross S? Is observe. 10 into 10. 10 into 100. So you got 1000 tuples. Into T you got 0. So you got, your answer is what? 0 rows. Observe carefully. This is how I have written answer as what? 0 rows. Now you tell me how many tuples in this, and I already gave you R cross R natural join T, how many tuples? So I want to answer for question number 4 and question number 5. Okay, and the database I already given you. This is your database. R has 100 rows, S has 10 rows, T has 0 rows. R and S there is a B common, S and T there is a C common. So using this knowledge, we want to solve few of the important questions. So observe carefully. This is the first question. There is a relation instance A and there is a relation instance B and there is a relation instance C. Now you see, first step is A union B. That A union B is going to do with a conditional join with C with this condition. Very typical query this is. Now A union B I am doing. So combine all the tuples together A union B. 12 Arun 60 15 Freya 24 and 99 Rohit 11 and these rows. 15 Shreya 24 is already available. Don't write one more time. And 25 Hari because union is going to eliminate the duplicates. 40 and 98 Rohit 20. 99 Rohit 11 is already there in the top table. Therefore, you need not write. So these 5 rows are going to cross with your C. So you observe carefully. I am doing a cross now. So C has got 10 and 99 only. So one time with 10, one time with 99. Need to do cross. Why to do cross? You may ask me a question. For any kind of a join, the first step is a cross. And we got the same step. So 12A 60, this time with the 99 and the same 99, 99, 99 and one more 99. So this is a 15, Freya 24, 99, 99, Rohit 11, 99, 25, Hari 40, 99 and 98 Rohit 40 and 99. So after doing the crossing between your A union B and C, he is asking a condition. What is that? A dot ID greater than 40. This is your A. Observe carefully. And this is your C. This C data, this is A data. A dot ID greater than 40. So it is not greater than 40. It is not greater than 40. But it is a greater than 40. So now observe carefully. We got 99 Rohit 11 and 10. You also see that C dot ID less than 15. What is C dot ID less than 15? One more is also there. Why? This A is mapped with this 10 and this A is also going to map with a 99. Therefore, you also have one more tuple which is greater than that and one more tuple which is greater than that. So let me write all together those tuples so that we do some kind of mapping. So 12 Arun 60. it is mapping with 10, and 12 Arun 60 mapping with 99, and next we have 15 Shreya is mapping with 10 and mapping with 99. Next we have 99 Rohit, it is mapping with 10 and it is mapping with 99. Next we got 25 Hari, it is mapping with 10 and it is mapping with 99. Every row is mapped with other two times. Now we got almost all tuples. Now you tell me, this is a dot id, this is your c dot id. So a dot id greater than 40, this and this is eligible. What are they? 99 Rohit 10, 99 Rohit 99, and c dot id less than 15, c dot id less than 15. So this is less than, this is less than, this is less than, this is less than. Got four tuples. 12 Arun, and you got 15 Shreya, and you got 99 Rohit, and you got 25 Hari. Now union is going to eliminate the duplicates. So 99 Rohit 10 is there, you eliminate 99 Rohit 10. So your answer is 1, 2, 3, 4 and 5 tuples according to this. Now you see, after doing this, so 12, 15, 99, and I am making a union operation to that. It is a making union operation, we don't require this. It is doing union operation here. So it is doing union operation here and it is doing union operation here. So how many union operation it is doing? Please see. So this is a first row 12 and 15, 99, then 25, then 98 and 99. So in that one tuple we are not going to consider, that is 99 Rohit and 11. And how many tuples we have got now? So 12, 15, 99, and the next one is 25 and 98. So 12, 15, 99, 25 and 98. So 12, 15, 99, 25 and 98. So 98 is the guy. Is that guy? 98 guy is Rohit. He is also trying to map with a 10 and he is also trying to map with a 99. Now this time, as 98 is a greater to your 40, so we are also going to get that. So 98 Rohit with a 99 and 98 Rohit with 10 also. These two tuples are also arrived. So after finishing that, we got 7 tuples. Once see this question. What is this question? R natural join yes. A is an attribute. We are pulling attribute A, R natural join S we want to do. So let R and S two relation instances over the relation schema R and S. So this particular relational algebra query is equal to who? As I told you, natural join is a commutative. Anywhere to anywhere you can write. I don't mind. But he provided that R natural join S is a mandatory. So R natural join S anytime to anytime you can write as it is associative, as it is also commutative. So I can write in such a way that so selection of A on your R natural join to S is equal to this. You can do in any style. Whatever answer you got on this R natural join S, and by performing this condition, you also will get the same. This is your answer. So this is another very important. There are multiple answers are there. This year onwards in GATE, multiple statement answers are there. You need to see very clearly. More than one answer chances are there from this year GATE examination onwards. There is a relation R of ABCD is given, and R1 is a one decomposition of your ABC, and R2 is another decomposition, that is AD. That means your ABCD is divided into two parts. Your ABCD table is divided into two parts. One table is ABC and another table is AD. As there is a common column, no doubt you are going to get a natural join. Otherwise, it should fall into cross product. Whenever there is no common column, then there is a chance the cross product. What he is asking, let us see. R1 natural join R2. These two are merging. When these two are merging, R1 natural join R2, you're supposed to get R. Observe carefully. When you get R, then it is a lossless join. Otherwise, lossy join only. Observe carefully. He is asking which are the two cases are under lossy join. Observe carefully. Which are the two cases are under lossy join. If you observe like this, so your R1 and R2, if I am doing, given the decomposition of your R into R1 and R2, we want to prove that lossy. So how are you going to see that whether it is a lossy join? Two conditions are there with us. One condition, R1 natural join R2, if it is a subset to your R, or R1 natural join R2, if it is extra than to your R, then we can confirm these two cases are lossy. Sometime, if R1 natural join R2 is not giving anything, if it is a pi, it is also lossy join. So now you decide what is our answer. R subset of S. So S is nothing but your R1 and R2 only. R union S is equal to R. Perfect. This is a perfect. What is that? When I combine your R and S, this completely is called as S only. S is nothing but decomposition. If I merge R and S, then you are going to get a what? R. And the other one is that R natural join S is equal to S. You're going to get the same data. And here R union S, if you union R tuples and S tuples, you are going to get R. The only one answer is left. What is that? This one. R subset of S is leading to a lossy join. And this one we don't mind because you are going to get original relation. That is the meaning of what? Lossless join. When you get the original relation, is lossless join. And the last variety of join is outer join. Very important. what the outer join is going to do. Outer join is going to do such a way that it displays a common data and a spurious tuple. Spurious tuple also you are going to get unmatched data. So there are three varieties of your outer joins. Left outer, which is symbolized like this, and the right outer, which is symbolized like this, and full outer, which is symbolized like this. Let me do some examples before closing this. Let us say RAB SAC. Observe every example, please understand carefully. There is a common column. 10B1, 30B2, 10C1, 40C2. Observe. He is asking, what is R left outer join S? First common data will come. What is the common data? This 10 and this 10 is a common. 10B1, 10C1 it will result. And 30 who are not having mappings. That's very, very important. R side which tuples do not have mappings. So 30B2 do not have mappings. That you need to write. If I am saying what is R right outer join S? Now first common data you write 10B1, 10C1. Now you see that next tuple do not have mappings. So that one we want to write. 40C2 do not have mappings with R. If I am doing all together R full outer join S, first common data will come. 10B1, 10C1, then left side unmapped one. 30B2 null null, right side unmapped one. Null null 40C. Now I want to ask you another task. So I have given you some tasks. Please answer to them at your own. I say R and S has got AB here, CD here, 10B1 and 20B2, 10D1 and 20D2. What is R left outer join? Yes, this is a task. What is R right outer join? Yes, this is another your task. And what is R full outer join? Yes, this is another task. And the last task is R natural join? Yes. Okay, my dear friends. So these are the tasks. You please solve them because these are very typical examples which you do not get often regularly. So there is some logic in this example. If you get logic in this example, the previous tasks also very simple to you. Okay, my dear friends. So these are the types of join operators which are there, especially in algebra. That is a cross, conditional join, equijoin, natural join, then outer join. Now tomorrow onwards, tomorrow schedule I said on YouTube, we are having 10 p.m. to 11 p.m. sessions. And the second, tomorrow onwards, on plus 7 p.m. to 9 p.m. we are discussing part 2 of DBMS. There I am going to discuss transaction management concurrency control. In that, don't miss it. Please subscribe Unacademy, my dear friends. Take the admission into Unacademy. While taking the admission into Unacademy, please see that my referral code is used so that you are going to be tagged on to me, to my batch. Use my referral code. Apart from the tagging, you are also going to get a maximized discount on that. Please utilize the discount coupons also. So once you get the admission, then you're going to see that unrestricted access. You can access anything. So be serious toward the competitive examination because there are some negative marking. That's what you need to observe. That negative marking, how to avoid. We are going to give some kind of a sessions, especially on plus course. Plus course is nothing but this course is for subscribed students only. So there may be a hike in you the prices of your subscription. That's why immediately join in an academy using my referral code. Thank you very much for spending and sparing all your valuable time. And tomorrow onwards, don't miss these timings 10 p.m. to 11 p.m. on YouTube sessions. That's a computer network. And Let's Crack GATE CSE is our YouTube channel. You go there, you're going to find my DBMS and operating system full length course lecture. Thank you very much, friends. Please do like my lecture, share these lectures with all your friends. Therefore, I'm going to get many more likes and many more comments. So that will be a big applause to me. Thank you very much. Stay tuned to me.